Hey class, welcome back. We're going to talk about this last section in chapter 3, 3.5. This talks about equivalent statements, and the notes there that you are given for this section start off with just a quick review. So let's run through these things. The negation of something is the opposite, and a squiggly or a tilde is its notation. And it's number 2, says, when is a conjunction true? A conjunction is true when both of the statements are true. That's your and. So true and true will make true. Question 3, when is a disjunction false? Disjunction, remember, is or. False or false make false. Number 4, when is a conditional false? When the antecedent or the if part is true and the consequent or the then part is false, then the answer will be false. And then the last one there, number 5, when is a biconditional true? And this is the one that had 2 parts. True and true make true. And false, if and only if, will also make a true statement. So there were 2 on those biconditionals. So that was just a quick review. And then this on the book, this starts on page 148. And number 6 here runs through and says, in your own words, what are equivalent statements? So this is what the book says. Equivalent compound statements are made up of the same simple statements and have the same corresponding truth value for all true-false combinations of those simple statements. In other words, when you do a truth table, you are looking for matching columns, and that way they have the same truth value in each one of the rows of that column. So, we start off here with example 1 on page 149. And it simply says, show that P or not Q and not P, if not P, then not Q are equivalent. And so you're given this table down there, and this shows what happens. So this is the basic P and Q that you should already automatically know. That one is an F. And then you negate P and you negate Q, and then you do these 2. So we're trying to see what is the deal between these 2 columns. And in order for them to be equivalent, each one of these columns and sections are going to have to match each other across there. So if we do P or not Q, then we get true, true, false, true. Because this is an or, so we need 2 falses between the P here and the not Q here, and that's there. So that one's false. And then the last column here says if not P, then not Q. So this is if true. So now this one has to be true, and not Q has to be false. So I'm looking at the pink. So here is if true, then false. The answer is false. It doesn't work anywhere else. That makes it all true. And therefore, these 2 columns have the same matching truth values. And so that makes these 2 statements equivalent statements. Okay. So then you're asked to do checkpoint 1 on your paper. And so if you'll pause your video, oops, just kidding. I already did it for you. It's on there. So if you did pause your video, then you can come back and check these answers. But the same thing happens when in number right below the call, it says circle the columns that are equivalent. So this one and this one, those match, they're equivalent. So to show equivalent statements, your truth values in your table just need to match up. So as long as you're doing your rules correctly, then there shouldn't be any problems with that. All right, so the next one says, what is the special symbol used to show that P or Q is equivalent? And that is 3 lines, not an equal sign, but 3 lines shows equivalence. Discussion we've had here in class would be, do you know what's the difference between equal and equivalent? So this is your equal sign and this is an equivalent sign, and they are not the same. But equal talks about numbers or values. So you can actually talk about money or something that, something that has a number to it. Those kind of things are equal. If you're talking about things, then they can be equivalent. In other words, have the same meaning and not the same number, because there's not a number attached to it. That's the difference between the two. All right, number 8. How do you form the contrapositive of a statement? Well, you're given a conditional statement. That's an if-then. And so we're going to reverse and negate the if-then. So we're going to switch these two, and it will say now this one becomes the if, and this one becomes the then. And then you would negate it by doing whatever the opposite is there. And then what is it going to be equivalent to? Well, the equivalence to it is going to be the actual original conditional statement. Those two things are going to be equivalent to each other. And this is called a contrapositive. Okay, you may or may not have heard that before, but a contrapositive is going to be reversing, or you could say switching, you could say flipping, you could say swapping. Lots of different words here, but we're just trading this side, the if statement, for this side, the then statement, and you actually change the words. Now it's if this, then that. And then negate it would be putting in the word not or taking it out. So number 4, it says read number 4 and then work the checkpoint. So if you're looking at the slide here, this is actually the answers to checkpoint 4. And all this was asking you to do was write the contrapositive of those questions that they were given. So you can read through example 4. If you live in Los Angeles, then you live in California. If we switch and negate it, it would say, if you do not live in California, then you do not live in Los Angeles. So the ones up here are checkpoint 4, and those are found at the top of page 153. So hopefully you have already tried those, and then you're checking them here. If you're not driving too closely, then you cannot read this. If it's time to do the laundry, then you have clean underwear. If supervision during exams is required, then all students are not honest. And then the last one doesn't have any words, but the original gave you the negation sign in front of the parenthesis and in front of the Q. So since we're negating it, we had to take it out, and then we've swapped sides with that stuff. Okay, so the next thing then is there's a table that you're supposed to complete, and this is what the table looks like completed. It was in the book on page 153 in the green box, and below there's another one that tells you the equivalence part. But really all this is saying is the conditional is the original thing, and you're saying if P then Q, and then there's what it would be in words, whatever it is. The converse, this is not the shoe. It says we're going to swap these two things. So now it's going to say if Q, then P. If Q, then P. Now the inverse goes back to the original, and it just negates both sides. So now we're going to say not if not P, then not Q. So if not P, then not Q. And then the contrapositive is what we had just talked about, and that's where you switch and negate. And so we're going to switch, flip-flop these things and negate both sides. So it says, if not Q, then not P. And there it is in words. And so up here it says, what's it equivalent to? And so remember, equivalence is in that truth table. And if you looked at the bottom of page 153, it shows you the truth table for any conditional statement, if P then Q, and it goes through each one of these and shows you the value of it. And what you see is that the conditional and the contrapositive both have the same truth values, but also the inverse and the converse have the same truth values. So the equivalence part of this is going to be the conditional and the contrapositive are equivalent to each other, and then the converse and the inverse are equivalent to each other. So that what does that do for you? Well, if you know that, then you don't have to make a truth table because you recognize it. If you don't know that, that's fine. Just do the truth table and you'll figure it out. So it's just a matter of knowing it or memorizing it versus just showing it on the truth table. No big deal either way. All right. The next one there is number 11, and it says read example 5 and then do checkpoint 5. And so example 5 was the following conditional statement is surprisingly true. If it's a lead pencil, then it does not contain lead. And you are supposed to write the converse, the inverse, the contrapositive from that given statement. So it goes through in the table there and it shows you switch it for the converse, negate it for the inverse, and then reverse and negate for the contrapositive, and then you're supposed to write the words. So number 5 for the checkpoint, if you'll pause the video here and reread 5 if you need to, and then try checkpoint 5 and then come back and you'll see the answers. It says, again, you are given the sentence, if you are in Iran, then you don't see Club Med. This is on page 154, down close to the bottom. And you're supposed to write the converse, inverse, and contrapositive of that statement. So here again was the given conditional. If you are in Iran, then you don't see Club Med. The converse, I just switched them. If you don't see Club Med, then you are in Iran. The inverse, back up here, I negated both sides. If you're not in Iran, then you do see a Club Med. So remember, this one said don't, so the opposite of don't is do. And then the contrapositive is going to be switching and negating. So go back up here to the original, switch them and negate them. It's going to say if you do see a Club Med, then you are not in Iran. Okay. All right, so that is section 5, and then there's one more question there on your notes, and it talks about De Morgan's Law. And De Morgan's Law is something that we talked about it in, we'll talk about it in chapter 2 in sets, and what we've said here is do not distribute this negation sign to each one of those. Because if you do, it ends up being the wrong thing. Well, De Morgan says, yeah, you can distribute it, but what you have to do is you change, or you have to flip this sign. So we would do not P and not Q, but instead of and, it would be flipped to an or symbol. And then vice versa, if you had P or Q and you distributed it, it now becomes from an or to an and. So we talked about this multiple times. We just said it's not true P and Q. It's not true P or Q. Well, when you negate both of those words, you're changing the meaning of the and to become an or statement. When you negate both of these with an or, you're changing the meaning to be and. And so you can do this now that we've talked about it, but you don't have to. So do not distribute unless you remember to flip the sign. What does this do for you? Well, it tells you that they're going to be equivalent to each other. And so why does that matter to you? Again, it doesn't really matter unless you are someone who wants to just know it. memorize it. But could you figure out that these things are equivalent to each other? Sure. All you got to do is a truth table with this one, and see that they will match up in the truth table. So they are equivalent to each other. If you distribute, you have to change the sign. That is the only way to make them equivalent. And this is in section 6 on page 160. But I'm not doing the whole section, so I just wanted to bring out De Morgan's Law so we could talk about it with the equivalent statements. That is all for 3.5 notes. This is your assignment. There's a few here with finding whether they are equivalent or not. When you get to these, they're 15, 16, 17. They're multiple choice, and you really only have to make one truth table until you find the correct sentence that's equivalent. So you don't have to do a whole new P and Q. You can just add on the new sentence every time. So if you get to doing these and you need a question answered, let me know what that question is, and I will help you with that. And then on page 162, it's going to do, these are going to be some of those De Morgan Law questions. So that's 3.5. That is the last section for this chapter. After this, we'll just finish up, review, and test is next. Thanks.